Okay, in the last video we discussed this energy diagram. I already told there that this dotted line, they represent the energy level of hydrogen atoms, and we have this 4s, 4, 3s, 4s, 4, 5s, 5, 6s are the energy of s orbitals of sodium atoms, and these are the p orbital of sodium atoms, these are the d orbital of sodium atoms, and these are the f orbital of sodium atoms. So here we have, this is for the hydrogen, so this is for the s, this is for p, this is for d, and this is for f. Now the selection rule is like we have transition occur from here to here, from here to here, from here to here, or from here to here. Also the transition will occur from 4s to 3s, or 6s to 3s, or 5s to 3s, or 6s to 3s. But among these transitions, some of the transitions are forbidden, and these forbidden transitions are done by using this selection rule. The selection rule is the change in principal quantum number should be an integer. It should be an integer. This is the first selection rule, and the second selection rule is the change in orbital angular momentum delta L should be plus minus 1. Now if I suppose that there is a transition from 4s to 3s, for 4s the value of orbital angular momentum is 0, and for 3s the value of orbital angular momentum is also 0, because L is equal to 0 correspond to S subshell. L is equal to 1 corresponds to P subshell, and L is equal to 2 corresponds to D, and L is equal to 3 corresponds to F. Now 4s and 3s, they have the same orbital angular momentum, which is 0. So it means that delta L should be 0, which is not equal to plus minus 1. So this transition is forbidden. So there is no transition from 4s to 3s, or 5s to 3s, or 6s to 3s. But if I look at this P, 3P, 4P, 5P, 6P, and this S, then for P, we have L value which is 1. And for S, we have L value which is 0. So delta L is here either it's 1, which is here the selection rule. Delta L is either plus 1 or minus 1. So we have this selection rule obey during the transition from P to S. So it means that the transition occur from P, 3P to 3S, 4P to 3S, 5P to 3S, and 6P to 3S. So it means in this transition, the lines obtained, the spectral line obtained from this transition is called principal series. This transition is called principal series. So principal series comes from the transition of NP to 3s, and N is 3, 4, 5, and so on. Like this line comes from 3P to 3s, this line comes from 4P to 3s, this line comes from 5P to 3s, and this line comes from 6P to 3s. For all this transition, delta L is plus 1. And this series is called principal series. Next we will see other transitions also. Now for 4s, L value is 0, and for 3P L value is 1. So delta L must be 1. So it means that this transition is possible, it's allowed from 4s to 3P. Similarly for 5s, L value is 0, and for 3P L value is 1, delta L is equal to 1. So it means that transition from 5s to 3p is also allowed. Similarly, for 6s, L value is 0. For 3p, L value is 1, delta L is equal to 1. So this transition is also allowed. So the transition from this 4s to 3p, 5s to 3p, 6s to 3p, we get a series of line, and this series is called sharp series. This whole series, I represent by the same color. This whole series is called sharp series. So sharp series is basically sharp series. It's comes from the transition from 4ns to 3p, where n is equal to 4, 5, 6, and so on. Like we have transition from 4s to 3p, and we have transition from 5s to 3p. We have transition from 6s to 3p, and so on. And for all this transition, delta L value is always plus 1. Now the transition from 4p to 3p is forbidden, because for 4p or 3p, the value of L is always 1. Like for 4p and for 3p, the value of L is 1. Here the value of L is 1, so delta L is 0, which is again the selection rule. Delta L need to be plus minus 1. Like only those transitions are allowed for which the value of L changes by plus minus 1. But here the value of L changes by 0. So this transition is not possible. So there is no transition from this to this, this to this, or this to this. So this is the sharp series, and sharp series comes from the transition from ns to 3p. N is equal to 4, 5, 6. Next we have, like for D, if I look at here, for D we have L value which is 2, and for P we have L value which is 1, and delta L is minus 1. So it means that we have a transition from 3D to 3P, 4D to 3P, 5D to 3P, and 6D to 3P. And the transitions which is due to from D suborbital to 3P is called diffuse series. This is called diffuse series. So here we have this is the first, this is the second, and we have the third one, which is diffuse series. And this series comes from the transition of ND to 3P. Like we have 3D to 3P, we have 4D to 3P, we have 5D to 3P, and for all these we have delta L value which is minus 1. So this series is called diffuse series. Next we have transition from 4F to 3D, 5F to 3D, and 6F to 3D, because for this, if we have L value which is 3, and for D we have L value which is 2, so delta L is always plus 1. So plus 1 is already in the selection rule, so this transition is allowed. And spectrum or series of lines which obtain from this transition is called fundamental series. This is fundamental series. So here I will write the fundamental series now, 4, which is fundamental series, and this series comes from transition from NF to 3D, and N value is 4, 5, 6. So these are the 4 series we observed in sodium spectrum. Now transition from 4F to 3P is not allowed, because if I say like transition from 4F to 3D is not allowed. And the reason is simple, because for 4F L value is 3D, no, not 3D, 3P. Transition from this F to P is not allowed, because for F we have L value which is 3, sorry. For F L value is 3, and for P L value is 1. If I calculate delta L, which is -2, sorry. So this transition is not allowed, because delta L value should be changed like plus minus 1. Here the change is -2. So transition from F to P is not allowed. So there is no direct transition from F to P. First electron will make a transition from F to D, and then from D to P. Similarly, if transition from D to P is also not allowed. D to S is also not allowed, because for D, like transition from D to S is not allowed, because for D, S value is, L value is 2, and for S, L value is 0. If I calculate delta L, which is 2. So this transition is also not allowed. So it means that electron cannot jump directly from F suborbit or subshell to S subshell. First it will make a transition from F to D, and then from D to P, and then from P to S. While there is a direct transition from S to P, or there is direct transition from D to P, or there is direct transition from F to D. So these are the 4 series we discussed for the sodium spectrum. It contains 4 series. One is principal series, which comes from the transition from P to S. From P to S. Then we have sharp series, which comes from the transition from S to P. And then we have diffuse series, which comes from the transition from D to P. And then we have fundamental series, which comes from transition from F to D. So here we have all these transitions. So now we will calculate, we can write the expression for the calculation of frequency of these spectral series. And the formula for the frequency of spectral series is for principal series, we have the wave number, which is equal to R over 1 plus mu s square minus R over n plus mu p square. This is for the principal series. Now here mu s and mu p, they are called, mu s and mu p are called Rydberg correction. This mu s and mu p, they are called Rydberg correction. R is the Rydberg constant, here we have S and P and the subscript with this Rydberg correction. They basically represent, like, this S represent the state where the transition is taken, and this P represent the state from where the transition is occur. Transition occur from P to S. So here this is the state where the transitions come, transition occur and to the state, and this is the state where from where the transition occur. Now this is for the principal series. So for sharp series, I have the same formula, but the difference will be the transition is in sharp series, the transition is from S to P. So we have this S goes here and P will come here. So the wave number of shaft series, the frequency of shaft series is R over 1 plus mu P square minus R over M plus mu S square. This is for sharp series, where M is an integer. M is an integer. Similarly for diffuse series comes from the transition from D to P. So the frequency will be R over 1 plus mu P square minus R over M plus mu D square. And we have the fundamental series. The fourth one is fundamental series. This is for the diffuse series. Next we have the fundamental series. And this series comes from the transition from F to D. So we have the frequency of this series is R over 1 plus mu D square plus minus R over M plus mu F square. So here these quantities mu S, mu P, mu D and mu F are Rydberg corrections. So this is all about what we call it, the spectra of sodium. So in the spectra of sodium we have 4 series. One is principal, the second is sharp, and then we have diffuse, and then we have fundamental series. Principal series comes from the transition of electron from P to S. Sharp series comes from the transition of electron from S to P. Diffuse series comes from the transition of electron from D to P. And fundamental series comes from the transition of electron from F to D suborbital. So I will stop my video here. In the next video I will discuss a little bit more about spectra of sodium. Thank you.